All right. It is Tuesday, January 23rd. Welcome to week 3 of CIT 225. I'm Brother Stevick, and I'm still teaching this class. Sorry I wasn't here last week. I was in Virginia on my other job, doing other job stuff. So tonight what I'm going to do is I'm going to cover all the stuff I would have covered last week and all the stuff I would have covered this week, code-wise. And then next week, I'm going to talk. Normally, this would be the week I talk about the final project and how it works. I'm probably going to do that next week because I want to get through all this code and I want to get caught up. So, so a lot of some of the stuff I'm talking about today, you've already done in exercises last week, and the other stuff will be for exercises. So I'm going to go ahead and share my screen. If I can find the button to do that. Let's see. Share my screen. Share that. All right. Put that away. Put that away. Let me get this. Okay. So this is what I want here. Yeah. Okay. So what we're going to talk about as far as code is concerned. So we're just talking about the basic ways to write code, how we simply write code, what the code does, and how we use it to do stuff. So a couple of things. First of all, there are two basic kinds of code that we talk about in this class. There's DDL. Let me get my little notepad up here so I can do this here. Notepad. Here we are. Okay. So there's DDL code. That stands for data definition language. And there's DML, which stands for data manipulation language. Manipulation language. Okay. So DDL, the data definition language, are any command that creates the structure that the data lives in. So it's a table, it's the codes that create the tables, that create the indexes, that create the columns, that create the data. All that is DDL, because DDL is what it's the building blocks of the table, not the data in it. DML, data manipulation language, those are the commands that insert data, remove data, delete data, select data, modify data, okay? So the three commands in DDL are create, alter, and drop. Obviously, create makes, alter changes, and drop deletes. So when we're talking about objects in the database, we don't delete them, we drop them. Okay. Our commands for data manipulation language are select, update, delete, insert, and truncate. Those are our DML languages. We'll talk about all of these today and tomorrow, this week and next week. We'll get into these later on in the course. So, and the great things about T-SQL, so T-SQL is the language that we use here. It stands for transactional structured query language. And the great part about T-SQL, as opposed to if you've ever like programmed in C++ or C# or VB or VB.NET or JavaScript or JavaSharp or anything like that, they aren't English. When you look at the code for C#, it gets confusing because they use words that don't exist in regular language. When you're looking at Transact SQL, those words are real words. Select, update, delete, insert. So when you're writing code for T-SQL, it becomes much easier to write because it makes sense. Because when I say select, we know what select means, right? So let's look at some of this code here. So when you're writing your queries in the IDE, anything that's a command turns blue. Anything that's a string turns red. Anything that's a comment turns light blue. And now we don't refer to those as commands, we refer to them to clauses. So there's the select clause, the from clause, and the where clause. Because they call them clauses because it's like a clause in a contract. It depends on what you're asking it to do. The select clause tells the query what columns from the table to use. The from clause tells it what table or tables to use. And the where clause tells it how to filter the data that's coming out. And then we got another one called order by. We're gonna get to that in a second, okay? So in this very, very simple, this query here, we're using equality comparison operators. So if we remember back to our old elementary school math days, we got greater than, we've got less than, we've got greater than or equal to, we got less than or equal to, greater than or equal to, equal. And these two here, the exclamation point equal and the two alligators kissing, that means not equal to, right? So here, select, my select command, get the title, get the column title and the column length from the table film, where, I've got my little clause here, length, the column length, has a number greater than 100. So I'm gonna go over here to my tables and look at this real quick. I'm gonna find the table film. And here are all the columns for the film table. So these are all things that I can select on, right? So all I'm asking for, tell me wherever there's a length greater than 100, show me the title and length of that film. I highlight it, I click my little here, and here's my results. These are all the films that have a length greater than 100 minutes. Man, a second, I got the wrong ones here. Hang on a second. Oops. Let me stop sharing for a second because I just suddenly realized this is the week 3 stuff, not the week 2 stuff. So I'll go here 1 second. Hang on. Stop sharing. Let me get my week 2 stuff. There we are. Okay. So let's try this again. Backing up a second. Sorry about that. Okay. So it's odd, but this one's a little more complex than I want to start with. So here I've just got select last name and first name from customer. Seems very simple now compared to talking about a second ago. So when I select this, it just gives me that, the first and last name of the person. It says last name, first name. Here's the column header last name. Here's the column header first name and everything that goes underneath that. Now, there is a function, and this is called a function called concat. And what concat does, it takes 2 text columns and combines them into one result. So here I've got select.
Brother Don, we did that because you shared the video from the previous semester.
Yeah.
We did this on that semester, on that video that you shared last week.
So you actually watched the video from last week?
Yeah.
Okay. I always assume no one watches that. So, okay, so we can just zip through this real quick. If you've watched the video, and if you're watching this video for the first time, go back to last week, watch last week's video, and I'll go ahead and jump to the other stuff. Is there anything here specifically I want to cover real quick? No. We got the concatenation description. That's fine. Okay, we're fine. The group by, order by. Okay, the one thing I know I reiterated a couple times in that video last week, but I'm gonna reiterate here. This average thing, this is called a aggregate. It's when they're taking a column that has numbers in it and aggregating down to a single value. In this case, it's giving me the average of the length. I think I said this 14 times in the previous video. I'm gonna say it once in this one. If you're using an aggregate in your select, you must have a group by in your query. Because if you don't have this, it ain't gonna work. All right, so thankfully, Pablo, let's go back over to here then. So here, we're in our where clauses, we're using our comparison operators. So we did this one here, we had from where the film is length is greater than 100. Over here, I've got select title, length, and rental rate from film where length is greater than 100 and rental rate is less than 5. So it's going to go through this and it's going to give me where both of these are valid because there's an and clause in here. So when I run this, I get 610 rows returned, and I get this. If I change this command to or and run it, now it will return anything where either of these match, where length is greater than 100 or rental rate is greater than is less than 5. Run that. I now have over 1,000 rows to returned. Okay. So you can take these comparison operators in your where clauses and link them out with an and, either an and or statement. All right. Here, select title from film where title is like a percent sign. When we use the like clause, so if let me do this real quick. So if I do here, where title equals Academy Dinosaur, right? I return this, I run this, and it gives me that there's one there, okay? When I have an equal sign here, it returns exactly what's in the quotes. It doesn't guess, it doesn't estimate, it's exactly what's there. Okay. When I use the word like, I'm telling it find something that's like something. So here I say select title from film where title is like the percent sign, and percent is what they call a wildcard operator. So it's going to find me anything that starts with an A and has whatever else after it. It doesn't matter. So if I run this, I get everything that starts with an A. Now, if I want to get fancier, I can say where title like A underscore E percent sign. Now, what this says is I want something that has the first letter an A. I don't care what the second letter is. The third letter has to be an A. I don't care what the fourth letter is. The fifth letter has to be an E, and then I don't care what follows it. Just show me what matches this pattern. So when I run this, first letter's an A, third letter's an A, fifth letter's an E, and then whatever else after that. And for all of these, so there's that. So you follow me? Follow?
Yes, yes, I'm following you. I'm falling asleep, but I'm still following you.
I'm sorry, I'm boring.
No, no,
I
it's
know,
not.
I get it. It's you're in Philadelphia?
Yeah,
Yeah, so for you and me, but for you and I both, it's 10 o'clock at night. I'm ready for bed. So,
yeah. I woke
but I
up
have
at 5 o'clock today.
me too. 4:45. Got to get the kids off seminary. All right. So we'll push through this. We got this, you and me. Ready? So here,
Yep.
where title not like. So where it here is like A, not like A, shows me everything that doesn't start with the. And I run that, and it shows me everything that doesn't start with the. If I change that to like, it shows me everything that starts with the, which is the one. And here I've got select title, length rate, rental rate from film, where length does not equal 100. So it'll show me everything but what equals 100. Okay. And it has to be exactly 100. So those are my so these are my equality comparison. These are my non-equality comparison. I can use this one too. This works just the same. Exclamation point, equal sign, does the same thing. I also have range operators, so I can say the word between. Show me where the length is between 50 and 100. Now that is between 50 and 100, inclusive of 50 and 100. So it's not 51 to 99. It is actually 50 to 100. And believe me, that does make a difference sometimes. Okay, and that gives me that. Now, when you're looking at something like this is what we refer to as a subquery. A subquery is a query that you put in another query, which is called subquery, that runs first to bring a result, and then uses that result in the larger query. So here I've got a select length from film where title equals Academy Dinosaur, and then I have a query here that select title from film where length equals whatever that length of Academy Dinosaur was. So if I run this on its own, it gives me a length of 86. So now I want just to see everything that has a length of 86. I can also go here where the length is, I can use a comparison operator. As opposed to a quality operator, I can use a comparison operator for the same thing. Okay. So the one thing, so now we're 5 minutes to the hour, and we're gonna end this in a few minutes. There's one thing I want to talk about that does get talked about a little bit. So the only thing I'm missing here, I didn't do the order by. So we have an order by clause in here. And what that is, it just puts thing in order. It's pretty self-explanatory. So if I run this with order by, it automatically does it descending, where it's A to Z. If I add descending, it does Z to A. By default, it's ascending. I can also do I think this will get confusing if I do it this way, but let's see what happens. I can do this. Oh, by the way, when you're writing queries, you can just drag and stuff the stuff over. So you don't have to actually type things out for the lazy people like me. So here I do select by title descending, right, with release here, but then I can do this where release year, I'm going to order by release year and do that ascending. So it's going to order the titles alphabetically descending, but then it's going to sub-organize it by release year ascending. So I got to find something that's so here. I don't know if this doesn't make that big a difference because there's not enough samples. Everything's 2006, so it's not going to make a difference. But actually, if I just did this instead, cover this where clause, and then ran that. Yeah, so here we've got, yeah, everything's 2006. So this database, so anyway, you can, the point being, you can have two specific things in the where clause, the order by clause, and have it do in different directions. Now, the one thing that gets talked about, I think it's this week in your quizzes and stuff, is how this query is actually executed in the by the engine. So when I refer to the engine, MySQL, SQL Server, Oracle, MariaDB, Postgres, NoSQL, they're all engines. And the reason why we call them engines is because they're constantly running in the background of your computer. Once you start running SQL Server or MySQL, there's something running in the background. There's a process going, so it's like it's on idle, right? So refer to the engine. So when we write this code and we send it to the engine, it doesn't, obviously the computer doesn't understand this. It's got to convert into what it understands. So it converts it into what we call machine language. I'm not going to get into what machine language is. You don't want to do it. It's a binary thing, blah, blah. But what happens is, it doesn't process this in the same way. We have to write it this way. Select from, where, order by. We have to write it that way. But when this processes in the engine, it goes a different way. So when this runs in the engine, the first thing that goes is the from clause. Okay? Because when you're dealing with databases, you can only manipulate data that exists in RAM. You cannot touch anything that's on the hard drive. It has to be in RAM. So you've got this giant database sitting on the hard drive, and you want to select from it, manipulate, update from it. So you've got to take that data and bring it into RAM, right? And this is why when you're designing databases, it's so important to understand how big your tables can get when you're using data types. Because if you're trying to manipulate a table and that table is 64 gigabytes, which is pretty small for a table these days, right? And your computer only has 32 gigabytes of RAM, you can't bring that entire table in. And that's going to cause performance issues on your computer.
Question.
Yep.
Because database nowadays so huge.
Mhm.
Like on my computer, I have 128 gigabyte of memory,
Right.
but they are so huge. Like those big companies like Amazon, Facebook,
Mhm.
those other dinosaur. Like their system, how many gigabyte of memory do they have to manage all that stuff?
So my computer, so where I work, the company I work for, we've got a server room and we've got database servers, right? They're in racks. And right now, most of the servers have probably around 5,000 gigs of RAM.
Okay, but then the computer that you access that, because those are headless system.
Mhm.
But your computer, your personal computer that you are SSH into those systems
Mhm.
have such amount of memory. How does that work?
So what do you mean? Like if I do a select query off of there and pull it
Yeah.
into my computer? So that's where we've just got to be careful because we're not gonna that's when you're writing your queries, you're making sure not to bring over, you're trying not to bring over everything, right? So you'll never do, I mean, doing something like if you have a large table, like for example, one company I worked for, and we're gonna talk about this probably next week when we talk about data types. They had a table that had 2 billion rows in it. It was the sales table, and
Wow.
the table was about um gosh, it was probably like the table itself was like 2 or 3 terabytes just for the table. And I'll tell the story of that table later. But so if I did like I would never do select star from that table because that would bring everything over and that would just compromise the entire system, right? So that's why you got to be very careful when you write the queries. You're only bringing certain things over. Now, I'm not going to get into it. Maybe next week when we talk about it, I can get into the details on how it can actually do. If I only have 64 gigs of RAM and I pull in a table that's 128 gigs, the computer will actually do it using paging files. But that's a whole other conversation, right? But yeah, so what happens is on your headless systems, when you pull the data over the wire, you've got to make sure that you're very careful. And a lot of times, when you're using a headless system in like a thin client, you're actually working on the server that has the 3,000 gigs of RAM, and you're not pulling it local, right?
Okay.
It depends on how your company's set up and how it's set up, but there's two ways to do that. So when you're running your query, the first thing that happens is the from. And what it does is it says, okay, you want the film table. So what it literally does is it goes to the hard drive and gets the film table and pulls that into active RAM immediately. So everything in the film table goes into active RAM. And then it says, okay, you only want these 2 columns. So it says get rid of everything else. So it gets rid of, sorry, no, so then it looks at the where clause and says, okay, we want to find that length table, that length column, and then I want to get rid of anything that doesn't match what this criteria is. So then it takes that film table, goes to the length column, finds what's needed, and then deletes everything else, and then just shoos it away. Then it says, okay, now we want to do the select. So we want to go, so now get rid of everything that's not title or release here. So all the other columns go away. So by the time that's done, all you've got is these 2 columns with this criteria met in the RAM, and then it does the order by. Okay. in this case where we have, and this is where nested queries aren't great. So with this one, and like I said, this runs first, right? So what happens is the query runs, it goes, says, okay, we're running this first. Let's get the film table, brings the film table over. Let's do the where clause, that does out the where clause and the select and gets the value. And then it goes here, says, okay, let's get the film table, and it go get the film table again. So when you do the nested queries, the process this has runs the same time, same way every time. So if you have the from film here and from film here, it pulls the table in twice. It doesn't use the pre-existing one. So from clause, where clause, select clause, order by clause is the way it goes in. Now, last week we had the group by clause. So it's from clause, where clause, group by clause, select clause, order by clause. And it's how it runs. Okay. So yeah. So with what we learned last week and what we talked this week, we'll get you the code through the code for this week. Okay. We have a couple quick ones. I'm not gonna design a database today. We're gonna do that next week. Okay, because we don't have time. But I do want to talk quickly about what the final project is, give the criteria for that, and kind of get you guys marching on that now, because you need to start thinking about it now if you're going to do it, because it takes about 9, 8, 10 weeks to do the final project. So the final project for this class is designing a database for a particular purpose, and create it and populate it and write queries off of it, and kind of imagine a front end that would go with it. So what we're asking you to do, what I'm asking you to do, is come up with an idea of an application that you really wish that you had. Something that would be helpful to you that needs a database. People in the past have done food storage tracking. Some people have done like an application that tracks parks and the perks the parks have. Some people have done something like actually one person did really cool. They did a food storage application that also had recipes. So you could say, do I have everything for this recipe? And it would tell you if in food storage you had the stuff to make the recipe for. Or it said, what can I make with what I have? And it would give you a list of recipes that you can make with in food storage. That's very super complicated, but it was a very, very cool one to do. So what you want to do is kind of figure out what you want to do, kind of the database you want to build, and then you need to provide the following to me for your final project. You need to create a database. That database must have 8 to 10 tables in it. Okay. Try not to go over 10 for some reason, and we'll talk about this next week when I design a database with you guys. In my experience, in my 20 plus years of doing this, once you hit 10 tables, it doesn't go to 11. It goes to like 35. It grows exponentially as you design tables, and you'll see why. So next week I'll pick something, and we'll go from 8 to 20 tables pretty quickly. The first 2 or 3 tables is kind of difficult to come up, and then they just kind of like explode out. So once you stop between 8 and 10, you'll be fine. You need to provide me the code to create the tables, the database. And there's a very fast and easy way to do that, and I will show you. Okay. I need what's called the ERD. The ERD is just the design of the database. It's a graphic. It's created by the engine. You just need to send that to me. Please make sure that it's in a JPEG or some kind of graphic format. Do not send the WMBs. The WMB files is the actual database file. If you send that to me, I can't do anything with it. Because my version of MySQL that I'm running is not the same as yours, and I cannot open your version of on mine. Okay. 8 to 10 tables, code to create the database, ERD. Then I need code to populate the tables. Okay. So you're going to write a bunch of insert statements to put data into those tables for me. And then you're going to send me 5 to 7 case studies. What a case study is as you design your database, you ask yourself, what are people going to use this for? How are people going to use this database? For example, if I was going to write a database for food storage, right? I would ask myself the question, a user might want to know what we have low inventory of. So I'd write a query, show me everything that's under, show everything that I have in inventory under 10, or whatever you think the low number should be. Show me what is expiring in the next 30 days. Show me what I have that is vegetable based. Show me the last thing that I bought. Show me how many cans of potato slices do I have. So that's what this is all about. I want you to think about it. How would this database be used? And write the queries to show me how the people use the database. 1, 2, 3, 4, 5. And then we need a PowerPoint or video explaining the database, explaining your project. Okay. So you make a PowerPoint presentation or a quick 5-minute video and tell me, here's what I did, here's what it was, here's the table I created, here's why I did it this way, here's the queries that I thought. And then optional, and this used to be required, but this year I'm making it optional because I get why they, so just so you know, if you're watching this video, you've heard me talk or read anything, you're not about to do what I'm going to say you're going to do. If you go into week 3 and find the project, you're going to find a whole different set of requirements. I don't use the requirements that are there because quite frankly, I don't like them. So I do these requirements. In those requirements, they want you to create a mock-up of a front end of the application to show that you know how it would connect to the back end of the database. That's been required for me for the last 7 years. It's optional this year. Mock-up of the front end. So basically, if you do that, and it's extra credit if you do it, you're going to just draw in some capacity, either using crayons, markers, Corel Draw, or whatever you want, what the front end would look like, the fields on the front end, and say, okay, this text box would connect to this database over this table over here. This button would trigger this. This box here would create. So that's what I want, right? But that's the criteria for the final project. It's not incredibly difficult. It is time consuming. It does get progressively faster as you get farther into it. The hardest part really is deciding what you want to do. And then the second hardest part is designing the tables. After that, it gets kind of easy. When you start getting to the case studies, most people go crazy and don't stop at 7. They go to 14 because it's just fun to write that code. So now keep in mind, I love doing this. When I started doing teaching this in person back years and years ago, the room I taught in, I had them they got panels from Home Depot that were basically just like whiteboards, and the entire room was whiteboards from corner to corner. And I would start in the one corner and design the database, and I would go around the entire room and design the database in 2 class periods. And we ended up with a database that was like 200 tables, which I just think is fun. So Now, the other thing is, if you choose to do the final project, you do not, your weekly papers are now, tell me how you're doing your project. Okay, so if you choose to do the project starting this week, for those of you in the sound of my voice, Pablo and whoever's watching this after, if you're going to do your final project starting this week, you no longer go to that prompt that says, it's your third week working for this company and you now know how to use where clauses. What do you think about where clauses? Your paper needs to be at this point, hey, Brother Sevic, I'm going to do, my project is going to be on, I'm going to create a database that tracks my temple visits. So I'm going to track I'm going to track all the temples I've been to, when I've been there, what names I did while I was there. I'm going to create this own application for me so I can track all that stuff. And I'll go, great. And then over the next 10 weeks, you're going to tell me where you're up to, what you're doing, ask any questions that you might have, show me your ERDs, and I will help you and tweak it and stuff. It's interesting. When we start talking about this next week and start designing databases, the same mistakes get made over and over again by people who first to design databases. And I'm going to go over those next week so you can avoid them. But when you do your weekly essays, you show me your idea and I'll say, hey, you need to fix this. This isn't normalized. You probably want to look at this way, maybe change this data type over here. It's just kind of me helping you and guiding you through the process. So that being said, that covers everything I needed to cover tonight. Probably got any questions? You represent the entire class tonight.
No, actually, I'm gonna rewatch this and go over this project.
Okay. So, and then, like I said, next week, I'm going to go through these first three. Okay. And we're going to design a database together next week. Which is one of my favorite things to do, because next week is joins, which is one of my favorite topics. We'll talk about that for about a half an hour, and then we'll design a database for half an hour.
One thing that I have noticed is that you don't have a favorite topic. Everything is your favorite topic.
I just love databases. There's a video. If you go to my YouTube channel and dig down, I've got like a 90-minute video just on how data is stored on a hard drive.
Yeah, well, it is interesting. To tell you the truth, I have done here on BYU Idaho introduction to Python, HTML, JavaScript, and so far the most interesting one that I like the most is database.
It is. It's because, I mean, here I'm gonna get on my soapbox here. The thing about databases is it is the most important thing a company has. You can get all the web pages that you want, but if a company loses its database, that's it. The company is dead.
Dead.
Yeah. And right now, like, how insane is it? Like, I mean, back when the internet was in its infancy and I would go to a website and try to like look something up, right? If I got a response back in like 60 seconds, I'm like, wow, that's super lightning fast. That's insane. Now, if I go to Amazon and I look for a product and it takes more than 3 seconds, I walk away angry. And that is all because that is partially on internet speed, but the other thing about it is it's all based on how fast that database returns your query. But it's for me, if I wasn't teaching this class, I would hate my job, my other job, because this reminds me how much I love databases and the process of making databases every day. Yeah. Right. So yeah, I've got all sorts of videos on my YouTube channel about like, why data types are so important. I could talk for hours on data types.
And the other thing that I like about it, which I consider is an advantage, it is far better than Microsoft Excel. Far better.
Oh yeah. I mean,
and far easier.
Oh yeah. Yeah. Excel is a database. It's a flat file. And thank you for not saying Microsoft Access, because no one should ever use Access. Friends don't let friends use Access. But yeah, when you look at Excel, it's funny. I can do incredibly complicated things in SQL Server, but I can barely do anything in an Excel spreadsheet.
Yeah.
I'm like Googling everything on how to do it. So yeah.
You know that my major is business here at BYU Idaho.
Yeah. Oh, it is?
I start with computer
Mhm.
technology, Bachelor of Technology. And then
Right.
at the end, I said, I don't think I like it that much because I did a couple of networking class, programming, and they are fun, but they are not for me because I am a construction guy.
Oh yeah. Oh, then you're gonna love databases because it's about
So
construction.
uh, so I decided let me do business, but I was kind of unsure. I didn't want to do accounting
Mhm.
because I consider it's a little bit boring.
Yeah,
And
it is.
I want to do some computer that helped me a lot because I'm using Microsoft Excel,
Right.
but Excel is not it's not that great. You know, if I want to do crazy thing with Excel, I have to use Python to make it interesting.
Oh yeah. Yeah. Yeah.
So,
If you're pulling Python into Excel, you're just entering an entire different world.
and then I decide, let me take one class of database because I was not registered on the database
Mhm.
course
Right.
on the certificate. I just took one class, introductory class.
Mhm.
Once I took that introductory class, then I went and I get the whole certificate.
Yep. Oh yeah. Databases. So when I started in this industry, I started as a Windows administrator. I got my A+ certification first back in 1999, and then in 2001, I got my Microsoft Windows certification. And I got a job with the company, and I was teaching A+, and I was teaching Windows Server, and they needed a database teacher. So I taught myself with SQL 2000, and that was it. I'm like, I never want to teach anything else again. I just want to teach SQL because it's just amazing. At that point in time, with that company that I was working for, I literally taught every Microsoft product there was: Excel, Exchange. I didn't teach the Office. That was someone else. I didn't want to do that. But Exchange, SQL, Office, not Office, Server, all that stuff. I was certified at one point in time. I was certified in every Microsoft technology.
I was
Um,
learning a lot about Microsoft because I was doing the help desk certificate,
oh yeah.
which I did the whole thing.
Mhm.
I have so many credit because I start the BYU pathway at the end of 2018.
Oh wow. Okay, so you've been here for a while.
Yeah, then I went, as I said, I went to computer.
Mm.
So I did the Microsoft stuff. But as I said, I didn't like it.
Right.
Even though I didn't like it. So I was looking for more. Then I settled with business. I said, I think because I have a bachelor degree in business.
Mhm.
So BYU Idaho sent the recommendation to do construction. I said, well, I didn't come here for construction. I already know that.
Right.
I already have a bachelor. So digging, and at the end, I said, okay, square. This is what I want to do. So I have not a couple of credits. I will be finished by 2026.
Mhm.
I just do 2 credits per semester.
Right. Okay.
I'm an old man. I'm not
Yes.
this. I'm not in a rush. I'm not
Yeah.
doing
Taking your time.
I'm not looking for a job. I already have a job. I'm doing this because of the knowledge.
Right.
I want to do more stuff.
Right.
But SQL, I think, on my opinion, is the best stuff there is on this class, in this online program for BYU Idaho.
Yeah.
It's one of those that make sure that you get a job once you finish.
Oh yeah. Yeah, you can, once you're done with this class and you have a good understanding, and the good thing about this class is it teaches MySQL and not Microsoft SQL Server or Oracle, but the T-SQL language exists in both of them. So if you understand database structure, if you understand how tables work, and you understand the code, you can actually go to any other database platform and be competent. Yeah. So
In a month, you will be like kind of a master already.
yep, absolutely. Well, sir.
I want to say thank you.
Oh, thank you. Thank you. I'll see you next week.
I'll see you next week, okay? And
Bye-bye.
anything, I'll send you a message, okay?
Okay, bye-bye.
Have a good night.